My name is Ellesse and I'm part of the amazing STEM response team here at the University of Wolverhampton. Welcome to our physics session, and in this particular topic we're going to cover the basics of energy. So what is energy? Energy is a key word used to describe the capacity to do work. And we're going to cover a few things such as kinetic energy and gravitational energy as well, along with work and power. So let's start off by describing what kinetic energy is. So kinetic energy is the energy of something that's moving. So if you are moving, you are making kinetic energy. So the formula for kinetic energy is on the screen at the moment. So it's half multiplied by the mass multiplied by the speed squared, which gives you the kinetic energy. And this is written as E with a small k. Moving quickly on now to gravitational potential energy. So this means that when an object falls, its speed increases. As it increases in speed, its kinetic energy increases. And the energy that it gets is from the gravitational potential energy that it had before the object fell. So the formula for this is on the screen below. So it's the mass times by the gravitational field strength times by the height of how much it fell. Now on Earth, the gravitational field strength is 9.81 Newton kilograms. So we would use this for the G in our formula. So let's go and work on a question so it makes more sense. An 80 kilogram person is in a lift which is raised 45 meters. What is the increase in the person's gravitational potential energy? So again, using the formula below, try and work it out and press play when you've got the answer. So if we remember, our gravitational field strength on Earth is 9.81. So that goes into the middle of our equation. The mass goes at the start, and then the height goes at the end. So we have 80 times 9.1 times 45, which gives us an answer of 35,316, and we simplify that to 35,300 joules, which is the gravitational potential energy for this answer. One thing you need to know in your A-levels and BTECs is conservation energy. So we all know that energy can't be created or destroyed. It can only be transferred and converted into other forms. So for example, if an object is falling down, the kinetic energy gained is the gravitational energy that it's lost. And similarly, if we throw an object into the air, the gravitational energy that it gains is converted from the kinetic energy that it has lost. So just to reiterate, energy can't be made, created or destroyed. It can only be converted into other forms. And that's really important to remember. So now we're just going to touch on work and power. And these are the two, some of the two key words that you'll need in your physics sessions. So what is work and what is power? What are the differences? So we can describe work as a force acting on an object that causes its displacement, and that is measured in joules, whereas power is the rate at which energy is delivered of the work done, and that is measured in watts. So work, we're moving the object by applying a force. That is what work means. For example, if we lift up a box, we're using work to move that box, and this is the formula down below. So work is signified by a W, and the formula for it is the size of the force in newtons times by the distance that the object moves in the direction of the force whilst the force is acting, and we measure that in meters. So here's a question to get you used to that formula. A 5 Newton force pushes a box 3 meters in the same direction as the force. What is the work done by the force? So remember, we use the Newton, that 5 newtons multiplied by the 3 meters to get our work of 15 joules. It's really important to remember that energy and work doesn't always go in the same direction as the force. So for example here, we have the example of pulling a sledge by a rope. The sledge is a horizontal force on the Earth's surface, but the direction of motion and the direction of force is being pulled up at an angle due to the placement of the rope. To work out our force in this, our work in this instance, we need to use trigonometry. And this is a formula below. Remember, if you need an update on trigonometry, you can watch our math sessions where we explain that in more detail. Okay, and finally, power. So just to reiterate, power is the work done every second, and this is the formula below. So again, it's measured in watts, and it's signified here as a capital P. So power equals the work done, which is in joules, divided by the time taken in seconds. So again, here's an example question. If 10 joules of work are done in 2 seconds, what is the power? There's a formula on the screen. You can pause it here and try to work it out and press play when you've got the answer. So we take the 10 joules of work and divide it over the 2 seconds of time, which gives us a power of 5 watts. So here's a harder question. A force of 125 newtons pushes a crate 5.2 meters in a time of 2.6 seconds. What is the power? You can pause it here and press play when you're ready. So first of all, we need to work out the work being done. And remember, we do this with the following equation, and the output of the work is 650 joules. Now that we have the work output, we can use that to find the power. So again, the power is the work divided by the time. So in this case, it's 650 joules divided by 2.6 seconds, which gives us a power of 250 watts. So that is just a really quick recap on some of the essential things that you need to know for energy when you move on to your further education studies. If you do need more help with formulas and maths and trigonometry, please do check out our math sessions, which are on our website and on our YouTube channels, which will go into these in a lot more detail. We hope you enjoy the rest of the series.